Everyone, and thank you for being here. So we have Nacho Fuentes with us today, and I'm Agustina Jaime. I'm from Magnet Europe. We're gonna have the pleasure to talk about computational design today with Nacho, that is an architect, a computational designer, and a curious man who is based in between Barcelona and Yucatán. Um, so he weaves digital precision with organic logic and makes amazing designs. Um, he's always aiming to create spaces, objects, and systems that feel both futuristic and deeply grounded. So, as I said, please write any questions through the chat that I'll read them at the end. We will have 15 minutes to ask Nacho any question. So whenever you're ready, Nacho, welcome and thank you for your time today.
Hello everyone. Nice to have this space here with my link. Thank you very much for having this space and being able to share a little bit of my knowledge. First of all, let's say that all the projects that you're gonna see here today are not just made by Nacho, are made by a team. Architecture is more a teamwork business than a specific person. So first, thank you to all my partners through all these years. It has been a pleasure working with them. And let's go. So today we're gonna talk a little bit about freeform to fabrication. I have glad to experience the freeform in my hands and in my mouth through all these years, and has been quite interesting. I think all these trip starts with I don't know, like myself. Agustina, I think she presented really good. But I'm an architect. I'm now a robotic fabrication expert. I'm working now in IAC, Instituto de Arquitectura Avanzada, Catalunya, and here in Barcelona as a faculty teacher in the master in robotics, in 3D and different masters that we in this house we are focusing. I was working also for different artists back in Spain, and also I work with Roth Architecture in Mexico, while I am right now keep working as a freelancer where I'm teaching. So I'm really happy to share with all of you this project and a little bit of Grasshopper. This I think all the trip about like organic architecture, freeform modeling has been started with Maria Mayo. Can I hear? Oh, sorry. This trip starts with Maria Mayo. I think a while ago, she was always sharing with me all the all the knowledge, and she was not a grasshopper expert, digital expert, but she was knowing quite well what is geometry, what is free form in geometry, how we start looking about how to create and how to start looking about nature. Nature, I think, was for me and for so many, I think, architects that I have been working with, one of the principal leitmotif to start looking and start learning. So this project was made with Maria Mayo in 2019 for the Biennale of Rabat 2000, and it was made completely about mycelium. Today we are not going to talk about natural materials, that I think is another full competition. We're going to talk about geometry and how we achieve geometry and look about organic shapes and or organic ideas. So just to give you a little bit of introduction, this project was really a game change for me for starting looking about geometry, how to fabricate it. This was a little bit before Sub-D, so we modeled everything in, I think it was Cocoon, the way that we modeled it. So for voxeling and applying this cocoon on the shapes and all the different parts of the structure and all the framework that we did for casting all these mycelium inside bags. And well, it was quite complex and interesting project that I have been glad to work with Maria. She understand nature. She understand what is relation between the cores, the shapes, the interiors, exteriors. So I think for me was really a game change start working with her and start learning about how to implement this in our design. So also I have the chance to work with Enrique Barrera in this other project that we did for an interior house for Alberto Chicote, Omecay in Madrid. This is a CNC fabrication file that, well, furniture that we were working for a restaurant. It was made completely in sub-D and also, with the features of the sub-D was hand modeling sub-D shapes. Today we are going to do a little bit of a grasshopper, but it was hand modeling sub-D shapes and all the CNC nesting and optimization was done in Grasshopper for fabrication. So also we are now working in this project also with Enrique Barrera nowadays. For Switzerland in another restaurant so that is already based on sub-D shapes, and we use those sub-Ds for segmenting and nesting these wood planks. It was quite interesting to see how all this shape becomes live when you start fabricating. The hand finishing, well, the only thing here was hand finishing we didn't do double sides milling, and we did just hand finishing over the CNC fabrications slides that we made. Then I moved to Mexico. I was working with another project. You can see a little bit more in my website, but I'm gonna focus a little bit more today in organic architecture and freeform. Mexico, I have glad to work with Roth Architecture and with a really amazing team of architects, designer, builders, fabricators. We were more than 100 people there working. So of course, all of the things that you're gonna see are not myself work, but I think are kind of all the office and experience that we through the years were developing on the studio. So in here, these shapes was developed with reinforced cement, so like ferro cement, steel mesh of a framework that has a really amazing strength where we're applying some concrete over it. And the thickness was quite light, quite thin, about like 10 centimeters thickness or even less sometimes. We were not sure controlling all the steps because it was handmade, all these things. But as you understand in these kind of geometries, you can start seeing the chords, seeing the shapes. Um, One interesting I don't know, word or that the Pulse Studio was saying that like this curve has an harmony or not. So when you start looking about complex modeling and how to make the shapes in digital, it becomes quite complex to develop and to understand what is the harmony of a curve. I think it's something that through the years I have started to understand what it is and to apply it a little bit through Grasshopper. So through the time that we were working there, we were like a really interdisciplinary team with architects, computational designers. We were building a fab lab. We were having a robotic celder, CNC, water jet, different like toys for digital fabricator, and also amazing workers with amazing skills, amazing modelers with sub-D sculpting, and I think all that combination has this answer of a building experience. If I need to design this architecture style, I will say a fairy tale architecture that we were looking not about just the use, more about the shapes and the experience in these modelings. So also in this studio, we were a really amazing team: Luis Rivero, Manuel Sandoval, Rodrigo Diaz, Lalo. Ruiz. So we were working a really amazing computational designer for more than 40 architects. So we were developing tools, developing different strategies for small tools for making the buildings happening. And I start analyzing and start modeling with a little bit more features and just sculpting the sub D itself. So we were sculpting the sub D, but we were having like a little bit features. I think as a teamwork, it was really interesting working with the architects and with the also we're having our own developed tools for fabricating certain things on the building that we're gonna go a little bit forward. So we did a little bit of structural calculations for form finding, to developing shells, to deform the shells, to start looking about how to make structures, how to reinforce the geometry, how to start making claddings, just attachments to the wall, how to have a primary, secondary structure, how to start looking about robotic fabrication. So now I'm gonna mix a little bit the webinar with a little bit of Grasshopper. So now I'm gonna jump on Grasshopper. We're gonna see a few tools and examples, and then we're gonna keep jumping back to the presentations to see this happening. So here, for example, this is I have prepared a few Grasshopper components that or a Grasshopper scripts that was helping for us to start looking or modeling those shapes. Of course, you're gonna see through the workshop that it has been focusing only to use sub-Ds, but if you understand a little bit more in sub-Ds, in general, sub-D are meshes who has different features. So a mesh could be is based on a low poly mesh. That is a goal about using sub-D, not having a high poly mesh that is not manageable. Working with a low poly mesh, and we have on the sub-D different features like creases. We have vertex crease. We have and then for example, talking about faces, we have triangle. Sub-Ds are more quads construct a mesh, but it also has n-gons and um, three edges faces, four edges faces, and so on, n-gon more than four edges. So also to start looking about that. For example, in this project, this is a small script is kind of a simple script where we were working with Rhino plugin here in Grasshopper. This allows us to start talking with Rhino and Grasshopper at the same time. So if you see here, each I have several cores, and each core has the height and the area that we define. But let me bake this course 1 second, and I am gonna select it through there is all the way, set multiple geometries. Actually, let me remove one of those. So here you can see that, well, of course, I selected and attached the geometry. Here, the script is quite simple. It look about what is the keys and value that a curve has, and it override it or use it for the operation. So in this case, in the height control, of course, the height of the volume, and the area, the thickness. But I'm able to control in Rhino through keys and values instead of going to Grasshopper and item selection, blah, blah, blah. I'm able to control curve with metadata attached. So at the end, the script is quite simple. It looks about the height, it looks about the area, and it makes quite a simple operation that is studying the geometry with the height defined, making a tree remesh and kind of cutting the bottom, and then kind of extending this bottom to have a kind of fix it with the course that we were making, and a small kangaroo for kind of relaxing a little bit the mesh. Um, and a quad-free mesh output with the sub-D that we are gonna keep working. So imagine that we are in the phase of making these geometries. So I'm able now here to go to keys and values and define the different targets that I want to change. So you see, now I'm able to Grasshopper, to Rhino, to define what are the different, you see has this green line is going to give you the reduction of the line. I was 50 was in the area, but now I changed the area. So I'm able to change this data related to the moment. So the good thing here that we were developing for the studio was a tool for the architects to start working kind of with a primitive shapes and start modeling quite fast for starting imagine and the shapes and the geometries. So, for example, once I like this result, you see, I'm able to move, drag, change a little bit the heights, change a little bit the keys and the values related to the curves. I'm able to go back to Grasshopper and push the content. Now, I'm here and now with a sub-D geometry, right? If you know sub-D, we can drag and drop. So now there is a time for maybe sub-D modeling, sculpting by hand a little bit. But also I'm gonna show you a little bit another tools that we have been developing for making the life a little bit easier for the architects. So for example, it was another tool was interesting. Oh, sorry. It was another tool interesting for us. It was how to insert curve. So for making this script happen, we also went for making a little bit of a GitHub. Um, well, GitHub here, I have updated to GitHub a little bit of a custom plugins for developing that Grasshopper component that you can download it. It's open source for everyone. So one is like a smooth mesh, and the other one is like it's like sculpting a little bit with the brush, and this one is like inserting a curve on a shape. So here, once I have that one, I'm able to come here in Rhino and start drawing. This is a custom plugin that we have developed for starting drawing on a sub-D. It's kind of the um, the I don't know the name of the interpolate curve on surface or draw polyline on mesh is more or less the same, but now with sub-Ds and interpolate curve. So now I'm drawing a little bit some operations that I want to do. I want to cut this window. I want to make this opening. Let me do a few more openings to make this a little bit more realistic. But at the end, um, I'm able to draw on the shape, and now I'm able with another script of Grasshopper to insert that geometry inside. So let me do other one here, and another one here, and I don't know. I think it's okay. Now I'm gonna go back to Grasshopper, and if you see, I have selected the geometry, and let me select one curve. So with this operation, I'm able to trim or not trim the curve, but I'm able to insert a curve. The curve that I have drawn has more points that they are looking. But right now, the goal here is try to be close by. And we still have some features to do that is kind of moving this curve out. And so I'm able to deform and place a curve or right now we are talking about massing. So now I'm gonna do this operation several times. So you see here, I'm able to start inserting certain curves and certain geometries here in my sub-D. So to have the way to make this happening, the goal here is to try to find, for example, a curve and where are the collision, the elements are the faces of the sub-D that are colliding with that curve and try to cut it and replicate it or try to insert another polyline inside. Because if you know, sub-D as we have to, with tab here, I'm able to display the actually mesh of the sub-D, no, the sub-D skeleton or sub-D mesh case, and I'm able also to display the final sub-D. Also here in these operations, I'm rebuilding the sub-D with polylines. I'm able to kind of start looking about how to um, having a certain tolerance about union. You see, when we cut this shape, we cut it through this point and this point. So when we make the sub D, that opens. But sub D, it becomes nicer when you have a nicer topology. So here, introducing kind of a tolerance about the vertices, I'm able to kind of weld certain vertices in the way that I want it. So let me do the last one here. So now, if you see, every time that I'm baking or applying, I'm pushing the sub D that I have modified. I'm deleting the curve that I have insert. Well, this you cannot don't delete it, but it might be interesting. Here, it gets a little bit more complex, but at the end, the result is about looking about where to insert a certain geometry. Let me go back 1 second here so we can see the interior because it was breaking. You see now the goal here is to try to find where are my faces that are in contact with the disc curve and cutting them and retrim it. So I just cut it with the curve and I am kind of rebuilding the faces with the new vertices. So through that process, I'm able to trim and insert different curves on the sub D. So let me do one more here. I'm gonna looks like it want to have a window there. Or actually, if you see here, it's kind of weird, right? There's certain operation that we can still doing in Rhino. Stitch, right? I'm gonna stitch these 2 points. For me, that face was looking kind of weird, no? What it was. And let me draw on shape. Another one. Okay, we have a nice output, but okay, this doesn't look like our buildings. Um, here, oh, sorry. Here, if you see that we are able to insert certain chords, right? We are able to, but those buildings has another curiosity that are these like the rainforest structure that is inside. But the rainforest structure that is inside, it gives the shapes to the building. So right now, for example, one interesting thing might be doing certain operations like kind of a kangaroo the geometry a little bit or form finding. So let me go here, kangaroo, right? We are able to select one sub D. So let me select the sub D, right? Do a small kangaroo. So we are able to form find this shape a little bit more before that we have done it on the pre kangaroo that we have done. This one, what is the essential part here? If you this building has been kind of reinforced with certain rods. So we are able to detect where are the lines that are making the network of the sub-D happening and start giving certain bending to them, right? So I'm looking about like having this course here, right? So this is a really simple operation that we on the studio make a little bit more advanced codes for that, but this I think is quite simple to understand what we want to do. We want to localize this polyline that is made from the sub-D topology. And we want to kind of active bending with it, make an active bending operation with it. So we are able to kind of bend and give shapes to the output through having certain rods that are a part of the form of the sub D as this curvature. This was a kind of a learning experience through construction. So if you see those rebars that we have here on those shapes, they are not segmented. They are not like G1 curve. It's kind of G2 curve, no? Grade 2. So sub D is really interesting because with sub D, we are able to develop degree 2 of curvature in all the shapes that in all the sub D that in all the free format that we are developing. But we need to insert certain constraints. So in this case, I'm able to do like a small kangaroo. You see, it's a simple kangaroo, but it has certain features that is looking about what are these network structure inside the topology or inside the building working. So once we like it, let me push it. So if you see, I have push, I have right now, well, it has deform again, right? I'm able to push the, I'm able to do the operation certain times. But the goal here is like the designers has these open tools open for them to start modeling and deforming the shapes according for their needs and their shapes. So now let me open another small kangaroo exercise here. I'm gonna go to math sub-T course. So imagine that we are developing a building here and we want certain windows to be equal one to another one because we're gonna order a framework from, or we're gonna order a frame of the window to a company, and then we just need to have a fixed dimension. So how to incorporate that in the sub-D? Here in this little sample, this little example, I'm able to start pushing certain naked edges. And here, well, here we have a small database about windows and shells that I can incorporate. The whole important value here is that like the topology of these polylines need to match. So if I'm looking this 5, 5, 5, it means like the number of, well, in this case, vertices that it has. So right now I'm gonna select what I want this curve. I want this curve here. So I'm gonna save the selection. I'm able, with an algorithm that I'm looking and I'm transforming the shape, I'm able to recalculate and position another window again here. So at the end, we have two windows that are completely the same. Also, I can do it several times with another one. For example, I want to insert that window here, that is my database, in this one. So I'm gonna save the selection and I'm gonna, well, I'm able to recalculate and find another position. It might be better, more convenient for us. But at the end, we are able to insert certain geometries. So, okay, we have deformed the shape, but how we arrive to these complexities? When we are starting to we are starting to analyze in these shapes, we start to analyze the strengths, the curvature, the how to build, how to don't fall, to so many things, so many parameters, sand analysis, environmental analysis. But at the end, one of the more crucial ones is structure and how through the different mechanisms that we made on site, that it was to strutting, and we started giving strength to the curve, right? It's not the same that we have a flat curve, so we have oh, so when it's not the same that when we are looking about something like this, right? Or that we are looking something like this, right? This, we are giving inertia here. So through, maybe let me draw it in a section, maybe, that is, so if we are having this curve versus this curve, right? This is more strong, right? Because this one has inertia, has height here. I'm looking now to start certain curvatures, no? Having a shape where it has something like this is become a beam here, right? When we are having certain geometries and we are kind of creasing and kind of opening certain operations here that makes height, right? It's gonna provide a stiffness of the structure of the shell, right? So here in this building, you can see that operation happening a lot of times. We have been kind of folding the sub D, to starting to have stiffness on the geometry. So as you see also here, through the construction process, you can really see these thread bars that we want, these rebars, sorry, that we were acting bending them to start building with these shapes. So let me do an example. We have three, four, five. Let me go here. Five, caramba. Um, we're gonna start looking about how to, maybe I need to, it's loading. 1 second. Let me select this sub D. Maybe I might not have it. Right. Let's wait a little bit to calculate again. Now I'm importing the course. I'm importing the shell, and I'm able to start looking about from this sub D that I had the chance to start acting bending, making the primitive sub D, making the first opening, the first operations. I want to look about what is the strength. And so through a small caramba, right, that we have here is a shell calculation caramba classic. We're able to see what are the, well, here I might need a few supports there because I was changing this geometry. But anyway, let's leave it like this. Right now, what I'm looking is about first structural calculation, and second, what is the compression and traction lines over the shapes, right? So when we are start analyzing, maybe I'm interested to look about these compression lines to start kind of mimicking like the way that these rebar were placed. So also, and we can give certain operations like deforming and other things. So here you can see I have detect those stress lines, and I'm looking more about the compression stress line. And with a really amazing plugin, thank you, Petras, about this. That is also how to start discretizing a network of lines, right? To have a really clean network. So through this method, I'm able to kind of quadrimesh again a sub D, a sub D mesh, right? Based on these guidelines. Through these guidelines that I have defined, there are the compression lines. I'm able to select these lines, and through different operations in sub D, I'm able to kind of deforming the mesh, right? The mesh based on those stress lines, and give another feature that sub D has, that are creases, right? If you see here, I have a low poly mesh. So this mesh is something that I'm able to keep tweaking and to keep deforming by hand in Rhino. That is the more interesting part here. Let me hide it. Here you can see kind of the result of the answer about placing those stress lines and creasing the edges that are nearby those stress lines. So I need to run a little bit more, but at the end, I want to show another example was with this reaction diffusion algorithm that we are able also to use those stress lines to define where are these patches and openings for the next operation, that it might be kind of opening more the geometry. You see here we have a lot of cracks, we have a lot of windows, right? So my sixth file, here in this file, we can see also what is the answer about that operation, right? If you, let me go for it. We have the sub D, right? We have the reaction diffusion of the algorithm running over the geometry, and we discretize. We separate between here, in this case, purple and orange, right? So we are able to kind of segment like a croissant our shape and geometry. And then looking about how to start connecting them. So you see here, the next operation is about how to connect all the curves together, how to start blending between orange and purple. and how to start blending the geometry. And at the end, these kind of croissant shapes kind of answer a little bit and look on the structural calculations for making these decisions. So there are, of course, is um, organic shape, freeform modeling, but at the end we have control about how we start modeling and creating all of these things. So through this process, we are able to start kind of connecting those shells. If you see through the operation here in the orange and the purple one, I move it up and I move it down. So instead of having this shell, I'm having this shell. So I'm kind of forcing more even the stiffness of the shells. So I'm able to kind of having kind of a structure like this. So we are able to kind of make it more stronger. Um, so but anyway, I don't know if we have a time to kind of go a little bit more in deep in here, but the goal is that we are able to kind of freeform modeling and keep modeling. So if I'm like, I don't know, manipulating the geometry, I'm able to manipulate also the output here. So this tool has been developed for the architects to kind of modeling faster and having certain ideas that we are looking for this fabrication. Okay, let's go back. Also, as you understand, like this shape was imagined on site, was not imagined on well, on a laptop at the end. But as the first point, before we all of the team we arrived there, these guys were doing it by hand and with really amazing tools. So, through different operation, kangaroo structure, climatics, all the computational team, we were looking about how to fabricate, how to prefabricate these shapes. So. Then we go to, I'm gonna run, Alula and clustering, right? A sub D is also a really nice structure about how we start looking about cluster, how to start looking about how we panelize and how we cladding. So these, of course, the shape of the cladding are organic shapes that are being based of k-mean clustering and another type of algorithms that we can have a look to go on it now. So this it was really interesting how to start having a sub D, that the sub D at the end is a mesh that you can go and make a high poly mesh when you need it, or making a V-red when you need it, and do a segmentation, cut it, trim it, so many operations that you can do on a sub D because it's the bridge between mesh and polysurface with degree 2 of continuity. So through making this, for fabricating all of these panels, we went to define our own custom mold fabrication method that it was master mold. This master mold was a way to project the shapes and kind of build with a little bit more constrained shapes and other methods that we with the same mold we were able to kind of build and fabricate all different type of shapes that of course were gonna get modified through passing through our master model a little bit, but it was kind of achieving the tolerance and angles and everything. So, and then I'm gonna talk a little bit about robotics. So through the experience that we have of these years, we did um, custom fabricated car with CNC milling and robotic milling that has been also, this card is fully designed in sub D. So it was really convenient for us to start segmenting, for converting it to polysurfaces and cut it and trim it and everything. And on the other hand, keep having a really smooth mesh and really smooth sub D to keep working and tweaking. And we were able to do really amazing parts on this car. Thank you again for all Roth Architecture team. It was a fucking pleasure to work with you. And also we had the chance to make this other Coral project that is made with sub-D modeling with so the more interesting part here in this project, I think, is sets of different length and angles that we were having in this coral looks kind of randomly placed, but every angle has been optimized to be like I think it was five different type of angles and five different type of bars. So with the combination of that, we were be able to kind of draw this complex geometry with and fabricate it with kind of a simple game. Also, now I'm working in Ajax. I have a pleasure to work with the Bandidos team, and we were working also with sub-D modeling and how to do non-planar slicing over a sub-D. So when sub-D become a mesh, then you start looking about meshes. When the sub-D become a polysurface, that is this example, it becomes a polysurface, you can do another operations. So it's really convenient. Here also, I want to talk a little bit more in robot fabrication for with freeform modeling. So when we are talking about, we were doing something in meters, right? But now we're gonna talk about millimeters. When we are talking about millimeters, Subtil has different features that are quite interesting for us, like the crease, so through this last example that I'm gonna go through right now. Oh, one second. Let's see. Okay, patch preview. Here we have a sub D, right? Sorry, it's in millimeters, so the scale changed. But anyway, I have a sub D here, right? As you see, this sub D has a different type of information here, right? So here I can see, right, through with this custom node that we make, it was where are our what are our normals and our normals for each vertices. So when sub D you have a mesh, right? And you define a crease. This is a crease, right? Imagine that we have something like this, and this line is the crease. What happening here? We duplicate the vertex. So normally, the sub-D has one vertex per vertice, right? But when it becomes a crease, this vertice becomes two, because this normal vertice, this direct vector of the normal, and this other one that is has been applied through in this point. So what is the convenience about that for robotic fabrication? So for me, I think it's quite interesting because you can start segmenting. Here in this file, I want to talk a little bit about segmenting. If you see here, oops, if you see here, I have kind of analysis on a shape. We have a little bit of a k-mean clustering for segmenting the shapes. So right now I'm defining, you see the patches, no, that I want to cut this sub D. By default, you see that those patches has really fit to the creases that I defined before. So I think is, let me bake one sub D actually, and we can see it in real time. Sec one sub D. Okay, so here, let me go shed it. Imagine that I want to, I don't know, um, deform the shape, or let me extrude here. Actually, let me extrude these ones here. It's gonna be quite terrible. You see, it's also starting with the segmentations. The segmentation is quite nice. Why we use these segmentations? If you see here, this analysis that we have on the right is the draft angle analysis, is how we achieve a surface, right? So when you have a surface like this, and you are trying to have a normal plane, or you have one vector of operation, in this case milling, right? I want to put the bead here around. I'm not able to reach this part here, right? Why? Because it's over 90 degrees, right? So 90 becomes blue here. So the goal that we are looking in this file is how to segment as a geometry based on the normals. So if you see, if I just ask to the algorithm make one cluster, it's okay, it's only one, right? You see the draft angle analysis, how what becomes, right? We have a quite blue, so we are not able to fabricate that easy right now. We're gonna crash with the robot. We're gonna crash. We are looking for making molds and for this shape, right? So if I'm asking to the algorithm to start looking more about 6 or, well, 30, right? If you have 30, of course, you're not going to have any problem. Here, the goal is kind of having this sweet moment when we have the minimum cluster as possible, right? And the maximum, the best relevance between the clustering. So right now, I'm doing quite well, right? If you see, I'm kind of fixing this clustering method packing through the creases, but it has been made automatic. Why? Because when I'm looking about the position of the vectors and the weight of the position and the weight is like how important is the position versus the normal of each face. But here it becomes more tricky because when you have this normal face really different than this one, you can start clustering the geometry with another methods. So here you can see what are the different operations that we are able to do a k-mean clustering. If you see, Nacho, if you are just segmenting the geometry, I have a really small kangaroo. I love kangaroo, by the way. Um, yeah, I have a really small kangaroo who is smoothing the geometry. So the output of this clustering is kind of something like this. No, I'm just selecting the faces. But with outside of that, I'm able to do a smooth patch um, algorithm that is just looking where are the creases here in the sub D and kind of fixing that creases or leaving it as a fixed value. So I cannot lose them anymore when I'm doing the clustering. And at the end, I have a mesh with a low poly mesh with a kind of smooth border between them. So this method become interesting when you are applying for each, how to say, display, let me take out the vertices, the edges. When you have for each cluster, you see one safe plane. So it's quite interesting because we are able to fabricate all this geometry without knowing what is the final shape of it, just modifying and clustering through machine learning, in this case, k-mean clustering, right? So we are able to fragment the geometry and having different safe planes through all the geometry. So if you see here, um, we were working with, I was working with Pete and Neil for with this workshop that has been a pressure also was working with them to making all these robotic fabrication system based on a sub-D clustering over sub-Ds. So if we go again to the blah, 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 kangaroo, and at the end, I might have this one. And this is a robotic fabrication file that we have developed for the workshop that it was wood milling. So as you see, we have per fabrication, how to say, a fabrication patch, safe plane where we were able to do jumps between layers and different operations. I think it was quite interesting to start looking about how we bring sub-D to fabrication in robotics. And I think also this is another project that we were working also with Pete in this forested that is going to be an exposition next week in Barcelona that is based also of sub-D clustering, sub-D creases clustering method for fabrication. I think that's all. I think I'm okay. I mean, it's 5 minutes,
Yeah, no,
55.
perfect.
I was looking by my watch all the time, like I need to
I was gonna,
run.
I was gonna interrupt and be like, don't worry, um, you have all the time you want. But that was amazing, Nacho. Honestly, thank you so much. Not only it's very interesting the projects, but it's quite interesting to see sub-D related to Grasshopper that we don't see it so much, and be able to see it within the project. I would love to see the expo in Barcelona, so I will ask you for more information about it. You said it was next weekend, no?
Yes, next week
Great.
start.
We have quite a bit of questions. If you're ready, I will
Yeah.
read them one by one. It's around 10 or 12 questions, but you've had such a good feedback from the chat also. Thank you everyone for staying and for participating today. So I'm going to go with the first question from Nader Belal. I'll try to read the names. I'm so sorry that might not be great with them. So Nader Belal says, how big can projects can get in terms of file size? And how did you implement the procedures to deal with the big file size? Also regarding project delivery, did you use BIM deliveries?
Actually, the files are super light because as you are looking, we are working with low poly meshes, so the files look super complex, and it has a lot of hours of hand modeling from our amazing team, but the size of the file is quite light. As handling for big projects, and we make able to start sending subdies to Revit. So all our submission was done in Revit. So sorry, I was not having the time to talk about Revit now today, but it was kind of it's interesting, and all the workflow that we were been developing through all these years was with primary modeling in Rhino subgs and Rhino inside Revit to start sending all the data there and start making blueprints, blah blah blah.
Perfect. I think we have potential to do 3 more webinars with all the information that we can see here. So Robert Narasi says, Ignacio, if it's not mentioned in your lecture, can you briefly tell us how you assess rainwater runoff, particularly over apertures with walkways underneath?
Well, through the process of modeling, imagine that we are modeling a plastering, we are sculpting. So the designers were able to open those files that I have been open in this webinar. Was another file was like a rain flow. So for example, you can run a rain flow analysis over your sub-D, over your geometry, and keep modeling. I think all the analyses are not for this is everything is okay. No, it's like everything is wrong. Let me change it. Like, I don't know. For us, the analysis was like, no, this is not gonna fall. No, no, this is gonna fall. Like, we need to do something. Or, no, we don't have light here. What are we gonna do? I think it's more the design's operations are based on analysis. So, as you say, of course, we run water flow analysis over the shapes and analyze them.
Sorry, thought. Just another comment. Eric Rivera says Nachin the machine, and I just needed to stop and say that. A
Thank
lot
you
of
very much, Eric. True love.
a lot of people ask if you can upload or share the Grasshopper file.
I might make a small GitHub update for this webinar with a couple of the examples that we have been looking today.
Perfect. And Hannah Campbell asked what was the plugin called? I don't know if it was
The what?
the plugin.
Plugin? Well, draw on shape. I think you can find it through Package Manager. The one that I use for drawing the course is draw on shape. And also in my website, go to feel free to deep in all the project that we have having the chance to see today. And over there you have the GitHub link, and you can check about the submissions, other things that I have been doing and updating through GitHub. And you have there, I think, a Grasshopper course and other things to take a look.
Great. Everyone that participated today will receive an email afterwards with all the links that Nacho will send me also, so you're updated with all of these. Next question is from Rama Hiva that says, are there any lessons expanding on the Grasshopper?
What? Sorry, I didn't understand that question.
Are there any lessons expanding on the Grasshopper? I'm guessing if you do any lessons or...
Well, I'm a freelancer. I do like custom plugins, custom developing things. Also, I'm working here in Ajax, so you can come here to learn, and we will, all the team that we have here that are amazing. We are glad to teach whatever you want to learn.
It's nice. Robert Narasi says, Ignacio, is your process of making the shell rigid with the creases beams an intuitive process, or do you use an algorithm structural analysis?
Well, in this webinar, you have seen that we have used Caramba to do the structural analysis over the shell for making the operations. But for example, in some of the fabrication that we were doing back in the days was we were modeling and then we were analyzing in Caramba and being back and forth with between because not always all the operations you can solve it through Grasshopper. So it was so many operations was solving, but hand modeling with Eric Rivera, Edison Azate, like so amazing modelers that on the office we were having the chance to work with, that they were able to modify the sub D by hand. Like it's like a sculpting. It's at the end, sub D is really about the sculpting, and in Grasshopper right now is like analyzing, maybe tweaking a little bit some certain values, modifying a little bit the shell, so it's a bit more structural reinforced, but keep being a really amazing tool in sculpting by hand.
Yeah, I guess you get the best of the both worlds because it's very intuitive to actually work with
Yes.
SubD. Um, Related to this topic, Sad Khan asked if there's a substitute plugin for Caramba for structural analysis.
I don't know. If you have open foot for Rhino, you
You didn't check.
you might have a
uh,
few.
Another
I
question.
Caramba is
Oh, sorry.
awesome.
Yeah. There's no need for a substitute.
Yes.
So Thomas Lindemann asked, well, he says amazing presentation. And what are the main strategies to get structural engineers to stamp off these bespoke structures? Did you ever have limitations or resistance in
Yeah.
that regard?
Always that we were talking about so with these shapes with the structural engineers, they were like putting the hands on their head and they're like, wow, guys, why? Why you are going to that path? But you just need to find a right person that is as crazy as you. That I don't know. I think it's more about that.
Um, Thank you. So Arapena says, is the structure a mix of rebar and bamboo, or are those cable pipes?
No, well, the pipes that you see on the images was PVC that they were made for drawing in 3D. So imagine that we have a cable. So this cable is a 3D line. So with those PVC pipe, we were able to 3D drawing on site, and the team from the construction were copying that bending. So that's why we use kind of a lot active bending in our sub D forming, form finding, because it's something that is gonna happen on the construction. I don't know. I think it's quite complex and it's like a really
Yeah,
long conversation that we can talk about that how to make those sub Ds and how to make those shapes. But I think active bending was a really crucial gate to open through the fabrication of those shapes.
I think it's defined. We are gonna need to do another webinar. So Benedict Oswald asked, very cool presentation. Did I get it right that you make this Grasshopper routine available on GitHub? Yes, we already answered that. And then GD Wells says, do you ever incorporate large format 3D printing into making these cladding pieces?
Well, now in Ajax we are working with in 3D PA for large scale 3D printing. But we have another methodologies that I'm not the more expertise there, but we are working on large scale 3D printed with the WAFS crane and everything here in Ajax. So everyone is welcome to participate if they want.
Ki Juan says, in the first case, how can accurate lofting be achieved in three-dimensional space?
I didn't understand it too. Sorry.
Yes, I didn't quite understand. In the first case, how can accurate lofting be achieved in three-dimensional space?
Lofting.
Lofting. I'm
Uh,
guessing like the command loft, like in Rhino.
Oh, well, there is a different method to make a primitive sub D and start modeling over. Love, like sub Ds in Rhino has a lot of, I think that has more than 50 or 40 commands. So imagine like we have chances to work in sub D as a loft, as you have more experience to work with sub D, with surfaces. So it has a different way to work with the surfaces and everything.
Hritik Jasnani asks what are some of the online resources that we can rely on to learn Rhino in depth and detail. I will answer that, and I will send if you want. If you want to write your email, I can send you some things. If not, also for those type of things, you can contact us at tech.eu@magnet.com. The next question is from GC Mohammed. The first pavilion that you have shown, I just want to know what is the material used and how it was used to be constructed. You have used some kind of framework. If true, how was the framework fabricated?
Okay, the first pavilion, I think it was the breathing space with Maria Mayo. That was the material is mycelium. Is mycelium in my website? You have 100 pages about mycelium research and fabrications. That if you want to go deep inside, you might have have some information there. To I think it's in Spanish. Sorry about that. But I think you can download the PDF and place it in AI and read about mycelium. And the framework was made with PVC. We project, we make a really rudimentary technique that it was projecting. With Rhino, we project with just normal projector over plastic, and then we were cutting by hand every pipe or every two pipes. So we were like the pants, right? The pants has the two sizes, right? The front and well, depends of the pants, but or here, right? I have this size, where we were kind of making flat, projecting, and then when we weld it, then it becomes like a circle, and we will fill it by hand. So it was also you have more information there in my website or in the website of Maria Mayo, explain all the process about that specific pavilion.
Great. I'm not gonna have time to read all the questions that were done while we were doing the Q&A, so I'll have one more. Second. And the plugins you use for analyze the subdivisions, Javier Martinez Castiola asked.
Analyzing the subdivisions. The one that I use at the end, there is some custom nodes that we were developing on the studio. All the other plugins that I have used today, I think are Caramba and Launchbox for gaming clustering, and also Launchbox for Quadrimesh. That also the Quadrimesh from Rhino is really nice, but I think both are really nice also to use it. So
Yeah,
not
maybe
sure.
we can comment on the on the plugins that were mentioned in the webinar when we sent the email. And so last one, Jordi Baez says, is there a fast way to bend all these curves rebars easily in order to create these concrete geometries? Saludos desde Marrakech.
I have working with Jordi making all those shapes, so he might know it quite well. That is just strength. Uh,
It's pure strength. Wow. Okay,
no, with
then
robotic process, you can do a lot of things. I think there is a remesh a project of ETH that is doing bending of rebars with robots. So everything can get done, Jordi.
amazing. Okay, thank you. Thank you so much. If you have any questions, as I said, you can send us an email or you can contact Nacho that he's showing his contact there. And amazing work, Nacho. Hopefully we will do another one. And thank you everyone for participating. I'll see you on the next webinar.
Thank you
Bye.
very much.